Hi, in today's video, I will be teaching about polynomial functions. Polynomial functions usually look something like this, and they can be affected by the leading exponent and coefficient, and depending on the exponent, if it is even or odd, this will lead to what the graph will look like. The exponents behind the leading exponent can also affect how the graph looks like. For example, 1/5 x to the power 5 minus 2x to the power 3 plus 9/5 x would have four curves on the line, which would look something like this. This is due to the leading exponent, which is 5, and so we would find the amount of curves by minusing the leading exponent by 1. But the curves are only present in some graphs, not all of them. For example, if we have y equals x3, it would look something like this. And if we had y equals x to the power of 2, it would look like this. So for the x to the power 3 graph, we can see from the left side it goes down, or if we wanted to say it more mathematically, we could say from negative infinity, from when x is at negative infinity, y is at negative infinity. Or we could just say when the graph is going left, it is also going down, and when it's going right, it is going up. Or we could say when x is reaching positive infinity, y is reaching positive infinity. For the x squared graph, it is a bit different. For both sides, from left and right, it goes up. So we could say from negative infinity, when x is negative infinity or positive infinity, y will always reach positive infinity. For two more problems, we will find the reciprocal, not the reciprocal, we will find the negative of that. So in this time, the graph will be flipped. So that means our results will be flipped. So instead of the left side going down, this time the left side goes up, as shown right here, where on the left side, when x reaches negative infinity, y is reaching positive infinity. Before on the right side, or when x is reaching positive infinity, y is reaching negative infinity, which is going right and then going down. And for the x squared graph, when x is positive or negative infinity, y is reaching negative infinity. So most graphs, any odd number graphs, will look something similar to this, as shown when it says negative x to the power 3, 5, 7, etc. Or when it says negative 2, 4, 6, etc. This can be the same for positive graphs, as shown in the last examples. So our problems will be match the polynomial functions with this graph. A is negative 2x plus 3. B is x squared x to the power 4 plus 2x cubed. C is negative 2x squared minus 5x. And D is negative 1/3 x to the power 3 plus x squared minus 4/3. All graphs are in intervals of 0 to 5. So the dashes represent 1, 2, 3, 4, 5, respectively. So for example A, negative 2x plus 3. This is just a line. This is not a polynomial. This is not a curve. So that already excludes all three other options besides the bottom left. So that means A is the bottom left graph. For B, x to the fourth plus 2x3. From what we have gained earlier, positive even graphs will be from when it's going right, it will be going up, and when it is going left, it will be going up. So that means it would have to be the bottom right graph, because of the leading exponent in the front. The leading exponent means that when it is going left, it is going up, and when it's going right, it's also going up. For C, negative 2x squared minus 5, it is similar to B, but this time the leading exponent is the leading coefficient is negative. So that means it is similar to B, but this time the graph is flipped over the x-axis. So that means the answer would be the top left graph, meaning the top left graph is C. So that leaves us with D being the top right graph. We can also find this by inferring that because the leading exponent is odd, that means that it should be going, when it is left, it should be going up, and when it is going right, it should be going down. If the leading coefficient was positive, instead of going right down, it would be going right up, and instead of going left up, it would be going left down, as shown in the past examples. Thanks for watching my video. Remember to like and subscribe.